Hello guys, welcome to this lecture. In C#, floating point numbers can be cast and converted to other types just like integral numbers. Okay, let's begin by discussing implicit casting. Implicit casting converts data types automatically and efficiently without losing any data. You should keep in mind that when working with floating point numbers, implicit casting is only possible from a float type to a double type. For example, here, we declare a float variable with value of 3.14, then we implicitly cast the float variable into a double type by assigning it to myDouble variable. As we told you, in C#, implicit casting can only occur from smaller data types to larger ones. So, it's not possible to perform an implicit cast from a double type to a float type. Also, the reason why C# doesn't allow implicit casting between float and double types to the decimal type is because these floating point types are represented in binary while the decimal type represents values using a base 10 numeric system. Now, let's talk about how implicit casting works between integral and floating point numbers in C#. Okay, C# doesn't allow implicit casting from floating point numbers to integral numbers. Can you guess why? This is because integral types do not support fractional parts, which can lead to data loss during the casting process. But, on the other hand, it's possible to perform implicit casting from all integral numbers to all floating point numbers. For example, here, we perform some implicit casting from integral to floating point numbers. Alright, it's time to talk about explicit casting. The first thing you should know is that all numeric data types in C# can be explicitly cast to each other by using an explicit conversion operator. This type of casting can be useful when we need to convert values between incompatible numeric types, for example from a double type to an int type. As you can see here, we explicitly cast a double type to an int and ulang types. But, as you know, this type of casting may result in data loss. For example, here, when we perform an explicit cast from this number to a byte type, it leads to data loss because the byte type cannot support fractional parts. Now, let's dive into VS Code and show you some examples. Okay, first, let's declare a float variable. Now, let's assign it to a double variable. Take a look at this line of code, where we cast a variable of type float to a variable of type double. As we said, when working with floating point types, the only implicit casting that can be performed is from the float type to the double type. So, according to that, if we say decimal, myDecimal equals myFloat, our code is highlighted in red. Or here, if we attempt to assign myDouble to myDecimal, this also wouldn't be possible. But when we put an explicit cast operator before the variable, this casting is possible. Now, let's perform some examples that illustrate how integral numbers are implicitly cast to floating point numbers. To begin, let's assign a signed number to a double type. Next, let's try an implicit cast from an unsigned integral number to a floating point number. Additionally, let's demonstrate an automatic cast from a native size type to a floating point type. As previously mentioned, one important aspect to note is that all integral numbers can be automatically cast to any floating point number without facing data loss or precision issues. Alright, let's illustrate an explicit cast from a floating point type to an integral type. For example, let's cast a float type to a byte type. Now, let's display it in the terminal. Save the file and test it out. This explicit cast was successful without any issues. However, if our float variable has a fractional part, the result of the cast leads to data loss. Therefore, it's important to keep in mind that when explicitly casting from floating point numbers to integral numbers, the fractional part will be lost. Okay, we're done for now. We'll see you in our next lecture.